Hi, folks. Want to give you a short video to help with understanding AI. And the first topic we're going to start with is large language model and why would I care? So let's get right into it in the interest of keeping this video short. The objective here is I want to give you a conceptual understanding of some of these acronyms that get thrown around by the tech media so that you will know what they're talking about, and along the way give you some memorable analogies that are going to be useful ways to think about this topic. Let's dig right in. Quick introduction to me, Dave Sisk. I've got a degree in engineering from many years ago, 2 decades of work in data and databases, recent master's degree in data science, pivot toward artificial intelligence, machine learning, data science, and all those topics that fall under the umbrella of analytics. My focus is on applied AI. So let's talk just a little bit about machine learning, since that is the engine that drives AI, and what exactly that means. So in a very simplified view of it, you take an algorithm and you take your data and you use your data to train this algorithm, and the output you get from that is essentially a machine learning model. You hand it similar data and it can give you a prediction based on the data that you trained it with. Now, most of the work for this goes into acquiring and prepping the data. That's typical. 70 or 80% of the work is generally the case. The testing of the model is involved. You may pick multiple algorithms to test at the end, toward the end of the process, and see which ones deliver the best results, which ones generalize the best. What that means is you want the model to perform well with data that it has never seen, because that's what you're going to give it in the real world. And this is an iterative process. You rinse and repeat this process until you get a model that has predictions that are accurate, having high enough accuracy, precision, and recall to be actually useful for your purposes. Now, this is what we're thinking in terms of structured data, like numbers, dollars, forecasts, credit limits, those sort of things, right? But we also build machine learning models with unstructured data, full text, documents, HTML text off of the internet, PDFs, what have you, Word document files, straight text. These are more complex. They take more complex algorithms. They take more time. They take more computing expense. They take more expertise of the modeler. It takes more of everything. They're more difficult to validate. So this is when you go from structured data to building machine learning models with unstructured data, the complexity of that grows drastically, is the point of this part of the discussion. So an important question becomes, do we really need to start from zero with this? So keep that thought in mind. The focus is pre-trained large language models. So what is an LLM? Why would I care? What is a pre-trained LLM? Well, someone somewhere did exactly what I just described. They took a bunch of text off of the internet, forums, public domain documents, books, dictionaries, encyclopedias, you name it, right? Wikipedia. They trained neural network models with this unstructured text data and tried to do it for general purpose uses. So the analogy here that's relevant that I want you to remember is this is like teaching a newborn baby to talk, read, write, do math, communicate, that sort of thing. This is costly and a very long endeavor. We're talking months, millions of dollars in computing resources. It is not a small undertaking. And they have published these pre-trained models in a way that they're reusable and extendable. That's the part we're interested in. That's the part where it's useful for applied. That means, here's your analogy to remember, instead of teaching a newborn baby from scratch to do some useful task, you could take the functional equivalent of, say, a high school graduate and teach them to do a useful task. Which one of those is going to be easier? The answer is pretty obvious, right? So, sidebar here, who's the they that I mentioned? We're talking, IBM, Amazon, Google, OpenAI, academic researchers, lots of really smart people have put their work into this. And this research has been going on for over a decade, but it's really only been late 2022 and early 2023 that we started to hear news about ChatGPT and large language models and vector databases and LangChain frame and other frameworks and that sort of thing. This is all very new stuff, and in fact, I'm recording this in November of 2023. It's less than a year old. All this technology is for the reality of less than a year old. So we've got a pre-trained LLM. That's great. Now, can we customize it? How do we teach it something new? Well, there's three ways to do that. One is typically fine-tuning, and that you should think of this as taking the training process that the model was originally trained from zero, and just giving it some more of that. And the output of that is a derivative model that has that additional training. And this might be standard operating procedure documentation, process documentation in your company, those sort of things, right? So this tends to have a very high expense, and the derivative model that you created is static. That's a disadvantage. The second way is typically called prompt engineering, and this essentially is in code. You put up certain guidance guardrails for the large language model to keep it answering in the right kind of context. For instance, maybe you're involved in healthcare, and you want the responses to be in the healthcare domain, or you're in finance and you want the responses to be in the financial domain, so that sort of thing. This is much lower expense, but it has the disadvantage that it's also mostly static, right? Now, the one that's newer and has lots of interest this year is RAG, R-A-G. It's retrieval augmented generation. This involves taking the large language model and connecting it to your transactional data and creating vector embeddings from that. And in this case, your transactional data might be something like, let's say, product reviews. That's a good example. The advantage here is that this is dynamic. This is moderate expense, but it's dynamic, and that's the part that's so appealing about it to the industry. If your data, if somebody adds, several thousand new product reviews, well, responses from that large language model are going to may change based on that new data that's been added. So there's the dynamic nature of it. So this is very appealing. Now, we should note here, when we talk about fine-tuning, the answer of what that includes depends on who you're talking to. If you talk to a PhD researcher in large language models, fine-tuning will be adding some training to that model and creating a derivative model. That's what they mean by fine-tuning. If you talk to most other people, like an executive, a developer, a data scientist, fine-tuning, that really kind of coincides with, they mean the same thing as customizing. It may involve all three of those, some level of all three of those things. Now, just keep that in mind when you have conversations with people about this. So, what do you get when you do this? Well, here's another analogy to remember. You've taken a high school grad and you've given them some specific job training. That's the fine-tuning. You've given them some guidance, some guardrails to keep them from going off track. That's the prompt engineering, and you give them access to transactional data that can change, and that is the retrieval augmented generation. So now, so that's a good thing. How do you do this? I want to keep this video short. That is a topic for another video, so keep your eyes open for that. We'll talk about vector embeddings, vector databases, KNN search. Those are where those things come into the picture. So the important take-homes from this short presentation: creating an EML model, a machine learning model from scratch, The analogy here is that is like training a newborn baby. You're starting from zero, starting from nothing. Using a pre-trained LLM, just as it is, the analogy here that I want you to recall is that's like hiring a high school grad. Customizing a pre-trained LLM. The analogy that I want you to remember here is that is like hiring the high school grad, giving them some job-specific training, putting up some guardrails to keep them on track, and giving them access to relevant data to use in doing their job. Those are the distinctions. So, this is the end. Thank you for watching. Feel free to post and let me know if you think that I achieved the objective that I stated. Have a wonderful day, and I'll see you in the next video.